Okay, we start at 10. Okay, let's go to our last part. Make sure you do your worksheet. So we have completed everything. I'll go over with you. And then you can mark, see how well you have done. Okay, let's go to our last subsection. A wave in motion. Electromagnetic waves. If you're interested, you can go and explore that in YouTube. Okay, we are interested to state the equation. Right? The equation for electric field, magnetic field. Then state the characteristic of electromagnetic waves. Compare electromagnetic waves and mechanical waves. Then state the formula and explain the significance. State the orders of magnitude of wavelength frequencies for different type of electromagnetic waves. Okay, electromagnetic waves. Right? That's how electromagnetic wave. That's the direction of motion, direction of travel, the direction of electric field. Right? Moving up and down, oscillating up and down. The direction of magnetic field, perpendicular to each. Is the same frequency. So consists of varying electric and magnetic field. Right? That's the electric field. That's a magnetic field. Two field, electric field and magnetic field are perpendicular to each other and perpendicular direction of travel. Right? That's your, if you like, that's your x-axis, that's your y-axis, that's your z-axis. Okay? If you like. Each field vibrate at the same frequency. Right? That means the electric field and magnetic field vibrate with the same frequency. They are in phase. That means they will go up. This one will go up to maximum. The magnetic field will go up to maximum. If it's zero, both of them are zero. That's what I mean by same phase. Okay. The other method produce electromagnetic wave. You can read your note there. It's quite good. I think I won't go further with you, but I will go into one of them. Right? Using, there's your alternating current. Right? That's your source of alternating current. Then you have antenna. Right? The current will, the electron will be forced to move up and down, or the current will be forced to be changed up and down. So electromagnetic waves are produced by alternating current source connected to antenna. Right? The antenna, American will call it area, I think. The oscillating charge can be considered to be due to alternating electric field. Then you can think as if since the charge is moving up and down, there must be a field on top. There must be a positive plate or negative plate below, and the two plates keep on changing. So there's an alternating electric field. That's how it produces electric field. Right? That's the equation for it to be traveling in the positive x direction. Alternating current, if you have an alternating current, remember our right hand grip rule. There's your current, there's the direction of the field. So if the current is changing, the field is also changing. That's why we have the magnetic field there, the red one. Same equation as the electric field, except we change the E to B, that's all. Okay, remember we are using a convention. Right? We're just using a convention. X, Y, Z. Right hand. From X to Y, there's a convention. That means we are just using normal convention. The positive is this to the right, negative is to the left. Positive Y is upwards, negative Y is downwards. That's all. And then we use our right hand grip rule. Right? Moving right hand. Right? where you have our moving from X to Y, and then Z is the thumb. Right? Z is the thumb. X to Y, Z is the thumb. So that's our right hand grip rule, right? Not inside. Z is not inside. Right? There's one to show you. Right? You can think of it that way if you want to. All electromagnetic waves travel at the same speed in vacuum, 3 times 10 to the power 8. Right? It can be infrared, it can be ultraviolet, it can be X-ray. As long as electromagnetic wave, they have the same speed. They can travel through vacuum, unaffected by electric and magnetic field. Right? Not affected by electric and magnetic field because they are not charged. Travel in straight line within limits set by diffraction. Right? We'll study about later about diffraction. Diffraction is basically passing through a tiny hole. Right? It's a transverse wave. So if it's transverse wave, it can be polarized. Right? That means you can force the vibration to be only in one plane. And then speed of wave decreases as it enters the medium. Right? Polarized means you can restrict the electric field in one plane. That's all. Right? It is unpolarized. It can be in any plane. It's in your book. Just got it from your book. A wave is said to be polarized if its vibration is limited to one plane. Usually light from a lamp is unpolarized. That means it will emit in all different, right? It can be vertical, it can be horizontal, vibration for electric field, then magnetic field will follow the electric field, that's all. Right? As shown by this diagram, it can be in any direction. So polarized means you put a filter, polarized filter, and then force it to move in vibrate in one direction. If you have two perpendicular, then nothing will come out. Right? We block all the light from coming out. Page 65. The difference between electromagnetic waves and mechanical waves. Electromagnetic waves produced by oscillating electric charge in antenna, or later on we will study transition of electron from higher energy level to lower energy level in an atom. Does not require a medium, right? Can pass through vacuum. Exists as transverse wave only. Speed is constant for all waves in vacuum. That means it can be ultraviolet, can be infrared. All will have the same speed. Mechanical waves produced by vibration of particles or medium. Right? This is oscillating charge or electromagnetic wave. This is the particle of medium that's vibrating or oscillating. Require a medium. No medium, it cannot pass through a mechanical wave. You need a medium. Exists as transverse wave. Example, water wave. Or it can be longitudinal wave. Example, sound wave. Speed depends on the physical properties of the medium. Right? It basically depends on the type of medium, whether it's such as elasticity and density. It means it depends whether it's in solid, liquid, or gas. Electromagnetic wave can be plane polarized. Mechanical wave cannot. And because it's longitudinal wave, it cannot be polarized. Okay, relationship between epsilon naught, mu naught, and C. Right? That's your permittivity of free space. That's your permeability of free space. Right? Speed of electromagnetic wave is given by V equals to 1 over, you don't need to know how you get this equation. You just need to know the speed of electromagnetic wave it's given by this equation. Right? If you are interested, you can go to American textbook. They will show you how it's derived, but we are interested only that, that's all. Then we put in the two value. Put in the two value for epsilon naught, mu naught, and then calculate out, we get 3 times 10 to the power 8. So this tells you, what is the speed of light? So light is electromagnetic waves. That's all we need to know about this equation. Calculation of the speed of light. Right? We got these two formulas, these two mu naught and epsilon naught and mu naught, sorry. Right? There's a value calculated is speed of light. So it means that is the speed of light. And light is electromagnetic waves. That's what the relationship tells us. Okay, you need to know the spectrum, right? Visible spectrum, right? There's a gamma, there's an X-ray, there's an ultraviolet, infrared. There's only the small spectrum called the visible light. And then you have a radar. Don't need to go to separate them all. Just need to know microwave and then radio wave. Right? Essentially, I think your book is wrong. Your book, I don't know why you can check textbook, you're not reference book. If you want to be sure, right? Your reference book is wrong already. Or your revision book is wrong already. Right? You can either remember the range of visible light is 390 to 780 nanometer or 400 to 800 nanometer. It's approximate only. Right? This one is taken from internet. You can memorize it by using something to help you. To me, I just use Roy Gibbs Big Bang. Right? R for red, O for orange, Y for yellow, G for green, and then after that, B for blue, I for indigo, P for violet. Okay, but essentially, I don't think they want you to remember all the different color. No, one end is red, one end is violet, one end is violet. It's N. Right? Violet, indigo, red. So red has the longest wavelength. Violet has the shortest wavelength. If you want in nanometer, you can change it to 3.9 times 10 to the power minus 7. Roughly memorize that. Right? 4 times 10 to the power minus 7 meter. You have to memorize the spectrum. Right? It's a continuous spectrum. That means there's no gap there. You got all the wavelength there, all the frequency there. Different kind of radiation merge into one another with no abrupt change in properties. Right? Radiation with the same wavelength and frequency have the same properties, but they may be named differently according to their origin, how you produce it. That's all. Wavelength range are only approximate. Right? Book will give slightly different range, but it's okay. But your reference book is wrong. Okay, so don't use that. And show considerable overlap. Right? Because sometimes we may call microwave as radio wave. Right? It depends on how you get it, but that's what it means by overlap. They are given to give you a feeling for the range of frequency. That's all. Okay, so how are you going to remember? I don't know. Right? But you need to remember. Either you remember the size of the nucleus, 10 to the minus 10. X-ray is size of atom. X-ray. Ultraviolet is 10 to the power minus 7. Cell will be your infrared, 10 to the power minus 4. Period, that means a full stop, is 10 to the power minus 1. This is microwave. Right? Or about 1 millimeter. Right? 1 millimeter, if you like. Microwave. And then 10-cent coin or 1 meter rule is a radio wave. Okay. Or you want to be more precise, then remember that. Okay. Start from 6 picometer. Separate the gamma and X-ray. Nano is ultraviolet and X-ray. Okay. So how you memorize, I don't know. You choose yourself. You need to remember, at least know how to differentiate which is X-ray. Right? You need to know the order. Gamma, this highest frequency, and X-ray, ultraviolet, visible, infrared, microwave, radio. Right? Another way to remember in terms of frequency, that means from 10 to the power 19 onwards, hertz to 16, right? 10 to the power 3 times. And after that is 2 times, 10 to the power 2 times. And to infrared is 10 to the power 2, 10 to the power 3, right? 10 to the power 3 from here to here, 10 to the power 2 from here to here, 10 to the power 3 from here to here, and 10 to the power 2 from here to here. Right? Or 10 to the power 9, 1 gigahertz is about radio wave there. Smaller than that frequency is your radio wave. Okay. Okay, so these are just different way of memorizing. You can choose one way to memorize it. Memorize infrared around here, ultraviolet around here. That means this one is 10 to the power 2, 10 to the power 2, 10 to the power 2, 10 to the power 2 different. Okay, that's another way. So your choice. Okay, we want a more accurate way. There's an accurate way, either frequency or wavelength. Okay, the order is important. Remember the order of the spectrum. That means where is radio wave. Right? They don't have to draw every time radio wave to the right. Radio wave can be drawn to the left. Right? Where increasing wavelength is to the left, increasing frequency is to the right in this diagram. Remember a typical value, right? For each section, like radio wave, microwave. Right? Remember a particular value you want to. Remember a rough range. Right? For example, for visible light, you need to remember 400 to 800 double, right? Nanometer. Okay, so this is all that you need to know for this topic. Right? As spend the rest of the time trying to finish your checkpoint. Okay, let's go to our checkpoint. It probably take 10 to 15 minutes. You can refer to your note while we do the question. Okay, let's go to 20.4. A standing wave has a wavelength of 0.4 meter, frequency 20 hertz, and amplitude at the antinode is 0.2. There is a node at x equals to 0. Write the expression for the standing wave. Okay. You may remember, you must know the standing wave formula. Usually they will ask you to derive first. That's the standing wave formula if you use sine. And you need to calculate amplitude, omega, and k. Right? From that, what is given here? So, wavelength is given, frequency is given, amplitude at the antinode is given. So, straight away you must know A is 0.2. Right? So, omega is 2 pi f. Right? Put in your frequency, 2 pi times 20. Calculate out, you can leave it in pi or you can calculate out completely. Radian per second. And you want to calculate your k. K is 2 pi over wavelength. Wavelength is given 2 pi 0.4. Right? Important to do your homework. That's why you are forcing all the formula into your head. If not, you will forget all the formula. Too many formulas to remember for physics. It's just like maths, you cannot study, cannot memorize all of them. That's the reason why you have to do your homework to force it in. Right? Calculate your k, so you're ready to write your equation. Right? 2a equals 0.2. A is 0.1. Okay, so that's your equation. Now put in your value. Right? At x equals to 0. At x equals to 0. Got this equation. Okay, so you want to write the final equation. You have to, there is a node at x equals to 0. Write the equation. So that's the equation. Okay, you don't need this one, because this one is just the information for your x equals to 0. Right? So basically, you have calculate your A, calculate your omega, calculate your K, and then put in the equation. That's all. Okay. Any comment? Anything not clear? Okay, let's go to number 2. A progressive wave has a wavelength of 0.5 meter, frequency of 20 Hz, and amplitude 0.4. At time t equals 0, the displacement at x equals to 0 is 0. Right? That means it's a sine curve they are using. Write the equation for the progressive wave if it is traveling in the positive x direction. Okay, know the general equation. This is traveling in the positive x direction where you got a negative sign there. And put in your, calculate your omega. Frequency is given. 2 pi times 20. And calculate your k. That k there, 2 pi over lambda. That's your wavelength. Put in your value. Calculate out. Then put in your value in. Amplitude. That's your amplitude. Put inside there. That's the first part there, OX. And number 2, negative. You just put a positive sign, that's all. Hey, why did it should be 4, sorry, not 5. Right? That's your 4 pi here. Why am I so careless? Okay, anything not clear?
Not clear, sir.
Deduce the expression for standing wave produced by the superposition of the two. Right? You are supposed to be able to write the equation, deduce. So either you memorize it or you derive it using your maths. Okay, refer to your note. If you then put in your value, right? Amplitude is 0.4 times 2, 0.8. Omega is 40 pi, 50 pi. K is 4 pi. Okay. What is the amplitude at point x equals to 0? Sorry, let's go to the equation. The standing wave is represented by this equation where t equals t is in second, the time, x and y are in meter. What is the amplitude of the point where x equals 0.5 meter? Okay. Remember, that's the general equation. That's the equation that's given you. Right? You don't have to follow the way we write, right? It's still the same, right? Just changing which come first, that's all. So A, amplitude. Right? There's nothing there. So amplitude is 1. Amplitude is 2A equals to 1. No? So amplitude at the point where x equals to 0.5. So now you just want to find the amplitude. That's the amplitude. Right? That's your y you want value of amplitude. So put your x value inside there and calculate out. And B, the phase difference between point 0.1 meter and point 0.5 meter. Okay, look, go back to the equation there. That's the equation. Right? Your K, that's your K. K is getting from X, 2 pi over lambda. So lambda is you take the K down, K is 25. So you get 0.251 meter. Okay, I put a question mark because I think your book give the wrong answer. So usually I will prefer not to use the formula lah. I would prefer to know that, right? They say the phase difference between 0.1 knot and 0.15, right? So you just know that's what, how does the equation look like for this one, right? Don't bother about that one. This is a cosine graph. Looks like something like that. So distance between the node is half lambda, right? Node and node is half lambda. Memory work is 0.126 meter. That's your lambda. Half of this one is this one. NA, that distance there is a quarter lambda. Okay, since the 2 points are on the same side of the standing wave, the phase difference is 0. Okay, you can calculate out, as I say, if you don't want to use this way, right? 0. You can put into the equation there to calculate where is your y, this equation. Right? Put your this one as 1 if you want to, right? Because you are interested only in amplitude. This one, you can put your x value and then calculate the amplitude, and then you will find the two of them are here. One is here, one is here. They are on the same side there. That's your wavelength. Okay, so mine one is just using no, roughly this is a cos graph. This is a cos graph. That's your wavelength. It's your wavelength from here to here. This is half a wavelength. This is a quarter wavelength. Right? 0.1, 0.12 is here. Okay, any comment?
Gotcha.
Right? Or alternative, you can use this method. As I say, you can either reason it out or you can calculate out. Right? Calculate out. There's your put in your 0.1 into there, calculate your y. And after that, 0.15. Right? That's your 0.5, this 0.1, then calculate your y. Right? And then you see that both of them are negative. So that means they are on the same side. So from there, you can deduce that there's no phase difference. So they are vibrating in phase. Right? It's not a progressive wave. So that's where your book went wrong. He used a wavelength and then used a progressive wave method to calculate. Cannot. Right? Because all this one move up, move downwards, all this one move upwards there. Okay. Okay, yeah, okay. The rest you can do yourself. Let's try some okay, our time is running out in a while. Let's try some okay. Which of the following statement is not true for electromagnetic wave? Not true for electromagnetic wave. What's the answer for number 1? Yep. Can refer to your note, your book.
A.
Not true. Not true.
Yeah.
No, donkey. It should be 1 over this one. Okay. Plane of vibration, electric magnetic field in an electric wave are, okay. What's the answer? Yep. What's the answer? They are all perpendicular to each other. So donkey. Okay. This one. Which of the following figures show the correct direction of electric field B and magnetic field E in relation to the direction of propagation of electromagnetic waves? Yep, what's the answer? Right, look at that. Right, you curve from E, the thumb is the direction of the travel, then you curve from E to B. Right, that's your thumb, direction of travel. Answer is C. Okay with that? Okay, number 4 and 5. Which of the following statement is true of electromagnetic wave, electromagnetic spectrum? Right, true. We want the true statement. Yep. Refer to your note. Refer to your note. Look at the spectrum. Okay. It looks like you have not paid attention in class, so I donkey. The rest I let you do yourself. Next Friday, I expect you to do some homework.
Yes, teacher.
Right? That's what I expect you to do. Focus 20. If you can do all of them, do all of them. Structure, I expect to do 1 to 7. Essay, at least one and 2. That's for next Friday. Right? If you don't do homework, as I say, you won't learn anything. That's why I can see it's a waste of time giving you tuition. You don't bother to study. Okay.
Teacher.
Yeah.
But then the SEM one, right? I mean, it's like stressful a bit, lah.
You should start learning now already and start spending time asking me, spend about 5 to 10 minutes every lesson to answer your question. You should start revising already. Don't wait already because you are going to repeat. So if you wait, you don't have time to study.
Just ask only, just study and ask.
Study and ask. Go through topic chapter by chapter and try to catch up with what I teach you. I'm going with you very slowly, hoping you will force it in by doing exercise, but problem is you don't do exercise. So that's why you see blank every time you come to class, blank. You forget everything. You don't revise. Right? Spend another hour, review through what I teach you and try the problem. That's how you're going to progress. If not, there's no progress. Okay?
Okay, teacher.
Bye-bye. Have a good week.
Yeah, thank you. Hello?
Okay, bye-bye.
Hello?
Yeah, bye-bye. Anything else? Okay, bye-bye then.